Hello viewer, I am Ghanashyam and welcome all of you to the electric neuron. Today we are going to discuss the problem on the power system analysis part 2. So before going to our video lectures, I want to tell you that if you like the video, then please share to your friend and also subscribe to this channel so that you will get immediate notification whenever I will upload a new video. So let's start our video lecture. So please read the question first. Let me read here. The maximum demand of a power plant is 60 megawatt given with a plant capacity factor that is 55% given. If the plant use factor is also 75% given, then what will be the daily energy consumed and the reserve capacity of the plant? So it is asking about the finding daily energy consumed and the reserve capacity of the plant. And here plant usable factor that is 80% is given. So first we are writing here the given data. So maximum demand is 60 megawatt and the plant capacity factor 55%. So we are dividing 100 and then convert it to 0.55 and the utilization factor is 0.80 from this 80% and this plant use factor that is 0.75 is given. Okay, so for daily energy consumed, we know the formula that is daily energy consumed in the one day there is 24 hours. So 24 hour multiply with the average load, then we will form the daily energy consumed. So for here not given any daily average load, so we are going to calculate first the average load. So average load formula that is from the this. I have already told you that key simple trick key average load divided by plant peak load or maximum load that is equal to load factor. So average load is equal to load factor into maximum demand. So here load factor into maximum demand, that is your average load. So here load factor is also not given to us and maximum demand is given, that is 60 megawatt, and load factor is not given. So for load factor we have already one formula. So put this formula average load divided by plant capacity factor that is equal to plant factor. So here, so for that we need to know the another two formula also, that is utilization factor. Utilization factor is equal to maximum demand divided by plant capacity, or maximum demand is equal to utilization factor into plant capacity and plant use factor that is equal to average load divided by plant capacity. So average load is equal to plant capacity into plant capacity factor. So here we know the load factor is equal to average load divided by maximum demand. So average load, put here this formula, that is plant capacity into plant capacity factor, and the maximum demand here that is equal to utilization factor into plant capacity. So here the plant capacity and plant capacity will be cancel each other and the only left out term is here utilization factor and plant capacity factor. So here plant capacity factor in the numerator side and utilization factor in the denominator side. So after applying this, here plant capacity factor is given, that is 0.55. So in the numerator that is 0.55. In the denominator utilization factor, the utilization factor is given, that is 0.80. So put in the denominator 0.80. After calculating these terms you will get 0.6875. So here load factor is formed. So put here in the average load, that is load factor into maximum demand. So that is equal to 0.6875 into maximum demand is equal to 60. So after putting this we will form 41.25 as a average load. So you have got the average load. So now you have put the average load here in the daily energy consumed, that is equal to 41.25 into 24 hour for one day. So after multiplying this term you will get 990 megawatt hour as your daily energy consumed. Like that it is asking about to finding the reserve capacity of the plant. So for reserve capacity, that is rated capacity minus maximum demand. So maximum demand is given to us, that is 60, and rated capacity is not given to us. So to find the rated capacity, we have one formula, that is average load divided by plant factor. So average load we have already calculated, that is 41.25 divided plant factor, that is equal to 0.55. Here plant capacity factor, that is equal to 0.55. So after putting and dividing each other, then we will form 75 megawatt as your rated capacity of plant. So now put here the rated capacity of plant, that is 75 minus maximum demand 60 megawatt, so that you will form the reserve capacity, that is equal to 15 megawatt. So that is your answer. Next, come to the problem number 7. So please read out the problem. So let me read. For the same data of question number 6, in the previous question, this question, the data are same. That means the maximum demand is equal to 60 megawatt, plant capacity factor is 0.55, utilization factor is 0.80, and the plant use factor is 0.75. All the data are same. Here plant capacity factor 55%, plant use factor 75%. What will be the maximum energy that could be produced daily? So it is asking about the maximum energy that could be produced daily basis. If the plant operating schedule is fully loaded, so plant is fully loaded at that time, what is the maximum energy that can produce daily basis? So when in operational and the average number of hours during which the plant is not service per day. So first we need to write the given quantity, that is plant use factor is equal to 0.75, and we know the formula, that is load factor is equal to average load divided by peak load or maximum demand, or peak load divided by average load divided by load factor. For a daily basis we are multiplying 24 hour here. So after putting the average load and the load factor, that is we have already calculated in the question number 6, that is 41.25, and the load factor is given 0.75, and 24 for one day we are multiplying here, then we will get 1320 megawatt. So for maximum energy produced daily when loaded divided by plant use factor, that is equal to number of operation of the plant. So put here maximum energy produced daily basis, that is 1320, and plant use factor, that is given 0.75 or 75. So after putting, you will form 17.6, that is your number of operation, number of hour of operation of the plant. Okay, and the average number of hour during when the plant is no service per day, that is for one day 24 hour minus number of operation, that is equal to 17.6, that is equal to 16.4 hour, that is no number of hour during where no service per day. Okay, so both the answer are formed, that is your answer. So now come to problem number 8. So problem number 8, a power plant has to meet the following load demand. Load A has the 60 megawatt from 8 am to 6 pm. Load B 50 megawatt from 6 am to 10 am. Load C 30 megawatt from 7 am to 12 am. Load D 20 megawatt from 6 pm to 10 pm. Load E 10 megawatt from 10 am to 6 pm. The coincidence factor for the above plant is. So here it is asking about the coincidence factor. So we know the formula coincidence factor, that is equal to 1 divided by diversity factor. So for diversity factor, we already know the formula, that is summation of individual maximum demand divided by peak of all the load. So summation of maximum all demand, that is equal to 60 from load A, 50 from load B, 30 from load C, 20 from load D, and the 10 from load E. So after adding all those, we will get 170 megawatt, that is summation of individual maximum load demand and divided by peak load demand, that is 140. So how it will be formed? For our simplicity, we are converting this time duration to this time duration, 6 am to 7 am, there is 50 megawatt. How it will be form 50 megawatt? From 6 am to 7 am. See here, there is 6 am and there is 7 am. So from this time to this time, 30 megawatt and 10 megawatt will be operated or will be formed. So after adding this, we will form 50 megawatt like that. In the 7 am to 8 am, there is 80 megawatt. So like that, 8 am to 10 am, there is 140 megawatt. Like that, all those from the 6 am, this point. So here the maximum or peak point is 140 megawatt. So putting here 140 megawatt as our peak of the load. So after calculating, the diversity factor will be formed as 1.2143. Now put here the diversity factor in the coincidence factor formula, that is 1 divided by 1.2143, that is equal to 0.8235. So this is your answer. Next, come to our problem number 9. So problem number 9 is saying that the peak load on a 50 megawatt power station is 36 megawatt. It supply power through the 4 transformers whose connected load are 17 megawatt, 12 megawatt, 9 megawatt and 10 megawatt. The maximum demand of those transformers are 15 megawatt, 10 megawatt, 8 megawatt and 9 megawatt respectively. If the annual load factor is 60% and the plant is operating for 65% period in a year, determine the demand factor and diversity factor for the power station. So it is asking about the calculating of demand factor and the diversity factor. So first we are writing here the given data. Power station rated capacity is 50 megawatt here, and the maximum demand of the plant is 36 megawatt, and summation of all the connected load of the transformer, that is equal to 17 plus 18 plus 9 plus 10, that is equal to 48 megawatt, and summation of all maximum demand on the transformer, that is equal to 15 plus 10 plus 8 plus 9, that is equal to 42 megawatt. And we have already known the formula, that is maximum demand into total connected load or demand, that is equal to demand factor. So demand factor is equal to maximum demand divided by total connected load, and diversity factor is the summation of all maximum demand divided by peak demand, that is equal to diversity factor, but we are not using first in the demand factor, so we are using this term. So that is equal to maximum demand by total connected load. So maximum demand is our 36 megawatt and total connected load is equal to 48. So after calculating, you will form 0.75. Like that, in the diversity factor you will form like this, that is all individual maximum demand, summation of all individual maximum demand divided by maximum demand on the power station, that is equal to 42 divided by 36. So 42 divided by 36 is equal to 1.1667. That is your all demand factor and diversity factor. So going to next, if the load factor of a plant, that is 0.60, what could be the possible range of loss factor? So there is one relation behind this load factor and loss factor. So this, the relation between the load factor and the loss factor is load factor square is less than equal to loss factor is less than equal to loss factor. So that is equal to, put here load factor is equal to 0.60. So 0.60 का square, that is equal to 0.36, and here load factor is equal to 0.60. This is your loss factor. So this is your range 0.36 to 0.60. Okay, for today that's it. See you in the next lectures. Have a good day.